Okay. Now we see the properties of the or characteristics of the dot product or the scalar product. First property is the commutative law. A bar dot b bar is equal to ab cos theta. Suppose b bar dot, we wish to write b bar dot a bar. B bar dot a bar is equal to what? It is the b dot a cos of the theta, which is equal to ab cos theta. Okay, means b bar, what is equal to what? A bar dot b bar, means b bar dot a bar is equal to a bar dot b bar, means the scalar product and the commutative. We can write b bar dot a bar or we can write a bar dot b bar. Suppose we have another two vectors c bar and d bar. We can write the dot product as c bar dot d bar or we can write d bar dot c bar. C bar dot d bar is equal to d bar dot c bar. So the vector scalar product of the two vector is the commutative. Okay, another property. Suppose a bar dot b bar plus c bar. How we can write is a bar dot b bar plus a bar dot c bar. That is, the scalar product is distributive over the vector addition. Third and fourth property is very important. Suppose a bar and b bar are parallel to each other. We have two vectors a bar and the b bar. Suppose these two vectors are parallel, a bar and b bar are parallel to each other. It means that angle between the a bar and b bar is what? It is a 0. The angle theta between the vector a bar and b bar is equal to 0. Theta is equal to 0, means cos theta is equal to cos 0 is equal to what? It is 1. So a bar dot b bar, the dot product of two vector is equal to ab cos 0, which is equal to ab. This means that if a bar and b bar are parallel to each other, the dot product between these two parallel vectors is equal to product of their magnitudes. Suppose if a bar is equal to b bar, a bar and b bar हे जर सारखे असतील, a bar is equal to b bar, how we can write a bar dot a bar? A bar dot a bar means what? It is equal to a dot a cos theta. And theta किती आहे? Theta is equal to 0. So a dot a is into cos 0 is equal to a square. Means the scalar product of a vector with itself is equal to square of their magnitude. This is the third property. Okay. Fourth property. Suppose a bar and b bar, these two vectors are perpendicular to each other. A bar and b bar are perpendicular to each other. Angle theta is equal to what? 90 degrees. So cos of the theta is equal to cos 90 degree is 0. Means a bar dot b bar is equal to ab cos 90 degree is equal to what? Is equal to 0. Means suppose if a bar and b bar are perpendicular to each other, the dot product between the two vectors is equal to 0. Or in another word, we can say that if the dot product of two vectors is 0, it means that these two vectors are perpendicular to each other. As the scalar product of a vector with itself is 0, we can write what? We can write as the scalar product of a vector with itself is equal to 0. We can write I bar dot I bar is equal to j bar dot j bar is equal to k bar dot k bar is equal to 1. And also this I bar, j bar and k bar are mutually perpendicular to each other, then I bar dot j bar is equal to j bar dot k bar is equal to k bar dot I bar is equal to 0. Okay, these are the properties of the scalar product or the dot product. In physics, the very well-known examples of the dot product are the work done. Work done is what? Work done means the force into displacement. Suppose initially the particle at a time t is equal to 0, initially particle is at this point. Okay. When the force F bar is acting on this, it displaces through and it displaces to this point through the displacement S bar. Means F bar is the force acting on this body and S bar is the displacement of that body. Then how we can write the work done? Work done W is the dot product of force into displacement. F bar dot S bar is equal to F cos into F cos theta into S is equal to Fs cos of the theta. The work done by the body is equal to work done is equal to force into displacement, or the dot product of the force and the displacement. Another example. Power consumed is equal to what? It is work done per unit time. Work done is what? It is F bar dot S bar upon T. But we know that S bar upon T is what? S is the displacement. Displacement per unit time is nothing but the velocity V bar. Put the value here. We get power is equal to force into the velocity. The power is the dot product of force into the velocity. These two examples are very well-known examples in the physics of a scalar product or dot product. Based on these properties and these examples, we solve the numericals for the scalar product.